Okay, so welcome to my YouTube channel. In this video, I'm going to talk about these two examples, right? Okay, let's talk about the question one. Okay, that is basically Laplace transformation of 8, right? I can write this as 0 to infinity 8 times e to the minus 60 dt and do the integral, right? So in this video, I'm going to use the properties I talked before, right? I'm going to use them. So what is that? Laplace transformation of 1 is what? I talked about that in the last video. What is that? That is 1 over s, right? Okay. So when the Laplace transformation of 1 is 1 over s, and also I talk about linearity. What is linearity? That is f1 k1 f1 time plus k2 f2 is equals to what? That is basically k1 Laplace transformation of f1 plus k2 Laplace transformation of f2, right? So in this video I'm going to use these two properties to solve these two examples, right? 2 to 2, right? Okay, so let's evaluate this one. Laplace transformation of 8. I can write this as Laplace transformation of 8 times 1, right? Now by the linearity I can plug it out from the Laplace transformation. So I have this Laplace transformation of 1 is 1, that is 1 over s, then 8 times 1 over s. This is basically 8 over s. Okay, so the next question number 2, Laplace transformation of a square plus 8, right? Okay, yeah, a square plus 8. Okay, by the linearity I can write this as Laplace transformation of a square plus Laplace transformation of 8, right? I know Laplace transformation of 8 is what? 8 over s, right? Now I have to figure out what is Laplace transformation of a square, right? So I'm going to take a square out, then I have Laplace transformation of 1. Laplace transformation of 1 is what? 1 over s. So that is basically a square over s plus this is 8 over s, like here 8 over s. So the answer is 1 over s times a square plus 8. Okay, I discussed about some examples here, so I hope you guys understood the property well. So in the next video we will prove another property. So thank you for watching. Take care.